Artificial intelligence, or AI, is the science of making machines smart, just like humans. Whether it's recognizing faces in photos, suggesting new music, or helping cars drive themselves, AI powers many of the apps and services we use every day. AI is the idea of creating machines that can think and make decisions like humans. However, there are many specific fields and techniques under this big umbrella. First, let's talk about machine learning, a type of AI that helps computers learn from data. There are different kinds of machine learning, and we'll start with supervised learning. In supervised learning, the computer works like a student being taught by a teacher. It is given a set of examples with the correct answers, and by studying these examples, it learns how to make predictions. Linear regression helps a computer make predictions using past data. For example, it can find a connection between how many hours you study and your test scores. Then, it can predict your score based on how long you studied. Decision trees help computers make choices by breaking decisions into simple steps. For example, they can decide if someone should get a loan by asking questions like, is their credit score high? Or, do they have a steady income? It's like making a decision based on answers to yes or no questions. Support vector machines, SVMs, work to separate data into different groups. SVMs are used to classify and detect abnormalities in medical scans, such as identifying tumors in MRI or CT images. Next is unsupervised learning, where the computer doesn't have examples to follow. Clustering helps computers group similar things together without any prior labels. Apps like Spotify use clustering to group similar songs by features like tempo or genre, helping to suggest music you might enjoy based on your past listening habits. Dimensionality reduction simplifies complex data by reducing the number of variables without losing important information. It's like summarizing a long story without leaving out the key points. Reinforcement learning is like teaching a computer through trial and error, where it learns by getting rewards for good actions and penalties for mistakes. In warehouse automation, Q-learning helps robots find the best routes for picking and delivering items by trying different paths and learning the fastest or most efficient ones. Policy gradients is a type of reinforcement learning method, where the computer, or agent, directly learns the best way to make decisions by improving its strategy, or policy, over time, instead of random actions. In short, Q-learning is more about finding the best action by trial and error, while policy gradients is about improving the overall decision-making strategy. Deep learning uses neural networks, which are like layers of connected neurons in the brain. These layers help the computer learn from data, similar to how our brain processes information. Convolutional neural networks, CNNs, are used to help computers recognize objects in images. For example, apps like Instagram use CNNs to identify items in your photos, such as detecting faces, animals, or landmarks. Recurrent neural networks, RNNs, are designed to handle tasks that involve sequences, like text or speech. For example, RNNs are used to predict the next word in a sentence when you're typing a message. Generative adversarial networks, GANs, are used to create new, realistic images from scratch. For example, apps that let you see how you'd look older or younger use GANs to generate those new versions of your face. Retrieval Augmented Generation, RAG, helps computers find important information from a big source, like a database, and use it to give a good answer. For example, chatbots like ChatGPT use RAG to search for facts and provide more accurate responses. Natural language processing, NLP, helps computers understand and work with human language. It allows machines to read, interpret, and even respond to things like text or speech. Examples are Google Translate and Siri Text. Classification is when a computer organizes text into groups based on what it says. For example, email services use text classification to figure out if a message is spam or not. Machine translation allows computers to translate text from one language to another. It helps people understand and communicate across different languages quickly and easily. Sentiment analysis helps computers understand emotions in text. Companies use it to understand customer opinions from social media posts or reviews. Named Entity Recognition, NER, helps computers identify important information like names, places, or dates in text. For example, when reading a news article, NER can highlight the names of people or locations mentioned. Computer vision allows computers to see and interpret visual information, like images or videos. It's used in apps that recognize faces, objects, or even handwriting. Image classification lets a computer label an image into categories, like how Google Photos organizes pictures. Object detection finds and labels multiple objects in an image, while image segmentation divides the image into parts, like separating a person from the background. AI powers robotics by helping machines perform tasks intelligently. For example, Amazon's warehouse robots use AI to detect objects like shelves and packages. Expert systems use knowledge representation to store key information, like medical facts, and an inference engine to analyze that data. Together, they help make expert-like decisions, such as diagnosing or recommending treatments. So, as you can see, AI is much more than just robots. It's in the apps you use, the websites you visit, and even the cars on the road. AI is transforming the world, one algorithm at a time. Thanks for watching. Keep exploring, because the future of AI is full of endless possibilities.